Okay, we are, I hope, ready for the last section of factoring. It's actually a very quick one. It covers any kind of things that was missed. So, for example, if you see a difference of squares, or if you happen to notice a, perfect square trinomial, of the two, I want you to pay special attention to the difference of squares pattern. So let's look at this little thing I typed up. In fact, I'm going to do it out here too. So first again, we'll start with multiplication. So 2x minus 3, and then 2x plus 3. Notice the pattern. These guys are the same except one's plus and one's minus. If you were to multiply them out, you get 4x squared, you get plus 6x, minus 6x, and then finally minus 9. What happens to the 6x's? I think you know. They cancel. So you're left with what they call a difference of squares right there. You see, what you have here is something squared. It's 2x squared minus 3 squared. It's the difference of squares. So if you happen to see that pattern anywhere, you get to factor it very quickly, in fact. So here's an example, a really tiny example. 49 y squared minus 25. Okay, what I have written out is, oh, you can tell it's a difference of squares pretty quickly because look, it's only two terms and they're squares and they're taking the difference. So it truly is a difference of two squares. Two terms, squares, subtract. That's what's happening on this thing. So what we have is, in the front end, you got 7x times 7x, or 7x squared, minus 5 times 5. So what happens is, you can very immediately jump to the answer. You just put a 7x here, and a 5, and a 7x, and a 5. And then, the coup de grace, one of them's plus, one of them's minus. Does it matter which one? No. It's done. So if you happen to see, I told you this is kind of a short section, if you happen to see a difference of squares, you should actually thank your lucky stars and go, oh good, these are quick and easy. You know what happens though? Right here, number 1, this is so easy that some students miss it or don't study it enough. They do, okay. And then the test comes and I put them on there and they forget how to do them. So you got to study this too to make sure that you have this under your belt. All we're going to do are these 3 examples. You ready? All right, first one. Look at it is a difference of squares. Second one, yeah, it's a difference of squares. I see squares. And the third one, I guess so. Yeah, it's fractions. You see the numerator, denominator? Differences of squares. So if I were to attack these, in fact, I'll stop. You can pause. You do them yourself, and then we'll compare. Okay, if I were to attack these, I'd say I'm square rooting in a way. 4 times 4 is 16. X times x is x squared. So really you're looking at 4x times 4x. What's this one? That's easier. It's 9 times 9. So answer, believe it or not, I'm ready for the answer. 4x 9, 4x 9. One of them plus, one of them minus, and we are done. These guys are helpful on your test coming up. You know, solve this equation. Okay. Simplify this fraction. Okay. In the next chapter. Okay. Another one. This guy is, what squared is 100? Got to think. Don't think 50. Don't cut it in 2. It is 10 times 10. So 10c times 10c. And this one's fun. Square root of 121 is 11. And it has a d, but that's okay. 11d. We haven't done any trinomials that have got like 2 letters in them. So ask questions in class. That was something I could have done last video, but I just didn't do it. Our answer here, believe it or not, we're ready, is 10c and 11d. And 10c and 11d, and then one of them's plus, one of them's minus, and we're done. It can go minus plus, it doesn't matter. The last one, well, 81, we've seen that before. This is 9, I guess you could say 9 over 8x times 9 over 8x. minus 5 over 6. See how I'm slowing down? 5 over 6. I'm not used to, I can just do these in my head because that's what practice does for you. So we're going to go 9 over 8x and 5 over 6, and 9 over 8x and 5 over 6. And what do we have to do? We put a plus here and a minus here, and we go home for supper. That's how difference of squares goes. Okay, obviously most of your work is going to be on trinomials, but do not forget this. Do not forget this. Study this so it seems easy to you. Okay, that goes for trinomials. They're going to be more challenging. Anyway, to finish this section, we go to the other portion of this, which is the perfect squared trinomials. Notice the difference. If I do, I'm going to do this up above it. If I go 5x plus 3 and 5x minus 3, I get 25x squared. I get minus 15x plus 15x, and then finally minus 9. And that reduces down to 25x squared minus 9. That's the difference of squares. And that occurs because of the plus and the minus. But what if they're both plus? If they're both plus, you get the 25x squared. There he is. You get the 9. There he is. But then you get the 15x and another 15x. They double. Instead of canceling up here, they double up on you. And that's because the signs are both the same, plus plus, and it also happens with minus minus. So a perfect square trinomial, what you do, and okay, so you don't have to learn this. Anytime you see a trinomial, you can factor it the normal way. But if you like to sense patterns, this is for people that are like, yeah, give me something else to think about. This time the x don't cancel and they double instead. And that's the pattern. Here's the pattern. The first and last terms are squares. So it's a square, something squared, and over here something else squared. And that's going to be, in that case, I think, added. And then you're going to have plus or minus the double term. So if you're looking, that's really rather sketchy, I know. So first and last terms are squares. The middle term is twice the product of their square roots. So here's an example. You've got 9x squared. Okay, you've got 16. So I'm saying it's 3x times 3x and 4 times 4. But in the middle, if you take 3 times 4, it's 12. If you double it, you get 24. So a person who's into this would say, it's a perfect square trinomial. It's 3x plus 4 times 3x plus 4. And oh, by the way, another way to write that is you can write it as 3x plus 4, the binomial squared. Okay? So these two are the same thing. You notice the use of the square. Square means multiply with itself twice, and that's exactly what's happening. So to finish off this thing, we'll do a couple and say that's enough. If you decide, I don't like this, you don't have to. You simply can go, I'm going to do it the old-fashioned way. Here's why. Here's why. Let me study the factors of 49. 49 are 1 times 49. You know what else? 7 times 7. Which one adds up to 14? 7 and 7. So you go plus 7 plus 7. There you go. Great. But if you happen to look at it, this guy right here can also be looked at by other students as y times y, and then down here plus 7 times 7. And in the middle, it looks like you've got, I made a mistake. Oh, I made a mistake. Do you see the mistake on the factoring? There's a minus 14. I went a little too fast. We need it to be minus 14. This is a good thing to talk about. I forgot. If you get the wrong sign, you've got to come along here and change their signs. This should actually be a lesson in the previous video. I got to do better, man. So when they add up, you get minus 14. That can happen. So we could start over again. I don't know. I was thinking this is a quick video. But the person looking at this could say, well, 7 times y, if I double it, I get the 14y. The negative tells you that the 7s have to be negative, okay? Yeah, that's bugging me that I did that. I don't want you to have to do this though. Oh, the factors of 49 are 1 times 49, but it could be negative 1 times negative 49, but that is true. 7 times 7, negative 7 times negative 7. Which one adds up to negative 14? That one does. Okay, finally. Sorry about that. All right, this one. All right. If we do it the normal way, we just simply go, or is there a GCF, 16, 40? And, no, there isn't. So what we have to do is, sometimes the perfect square trinomial does help you. I would maybe look at this and go, I think it might be. Only once in a while does it jump out at me like that, though. So typically, you can start off by going, okay, this is how it's going to go. Look at the factors of 16. 1 times 16, 2 times 8, and 4 times 4. But they could be negative. In this case, we don't have to worry about it. And 25. 1 times 25, 5 times 5. We are spaghettiing our way, hopefully, to 40. You ready? 4 times 5 is 20. 4 times 5 is 20. They add up to 40. We're happy. So we write our answer. It's going to be 4x, 4x. Is it just 5? No, there's a y on the end. 5y. 5y. And they should both be plus. Some of you want to scream at the video, man. Tell them about how do you know the signs of the numbers. There is a game you can play with the signs of the numbers. I might tack this on for free. So if you're looking at a polynomial, it could be something like 3x squared minus 2x minus 14 or something. I'm not saying it even factors, but what happens is you can actually look at the signs here. If I used to do this in a table, if the signs are like, let's say minus minus as they are here, they're going to be, your answer is going to be a parentheses plus and a parentheses minus, and the bigger guy is minus. You might see a thing that goes, let's see, plus, minus. Well, in that case, it's going to be plus and minus in your binomials, okay? Because your product is negative, but this time the bigger guy is positive. You might see a problem that says, let's see, now we're going to go with the pluses, and this is minus. Okay, that's interesting. Well, in that case, your binomials are both going to be minus because they multiply to make positive, but the sum is negative. And then finally, the easiest one is plus plus. You're going to have plus and then another binomial with a plus in it. And so I don't know if that helps you guys. Yeah, I feel remiss for not telling you like some more shortcuts, but anyway, I'll leave this in the video. Yeah, this last problem reminded me of it. And that's about it. I thought it would be shorter than that, but we actually handled another part of the whole factoring business. Okay, see you later.